Hello YouTubers, today we're going to set up an LED wall. We're going to do 7 panels wide and 2 high. This is kind of a typical situation that we do a lot. It's not as big as some of the other walls, but it fits in a lot of spaces really well. We've got a couple different varieties of LED panels, and one of which is our new panels, which are our 2.6 panels. They come in these black cases. And then we've got our older 3.9 panels, which are in this case. And they fit 6 per case. And they sit kind of like that, which is kind of nice and easy, which is really, really great. And then these road cases have little windows on the side so we can see if there's panels in them. Because when we have a whole pile of cases, it's really nice to see which ones are full and empty. Inside these panels, we have our new 2.6, and these are all, actually this is our utility case that's got all of our cables. And in this case is our panels, and these are our new 2.6 outdoor panels. So we have outdoor panels, we have indoor panels, and so we're going to be setting these up. All right, so these are the 2 different panels that we have for outdoor, the large 1000 millimeter by 500 millimeter. We do have 500 by 500, which are just the squares. But these are our older panels, and these have a giant power module on the back of them that, you know, if you've got a card that goes out or a receiving card or a power module, you have to open this case, unscrew a bunch of things, and it's really kind of clumsy. If you've got a panel that goes out, or if you've got a section of it that goes out at a show, you've got to pull apart all of the other panels to get to this panel wherever it's at, and that is really complicated. Luckily, we haven't really had to do that very often. These are our new panels. They've got PowerCon in and out, and they've also got the EtherCon in and out for networking. But these have individual sections in each one. So there's 8 different little, they're not really quadrants, but I guess they are, that pop out, and you're able to change them out without having to remove the entire panel. And then if you've got a power module that's going out, you do just a couple little snaps like that, and you can pull the entire power module right off and then swap it out quickly while it's still up on the truss. So you don't have to worry about having to get screwdrivers and all that. So it's super easy to use. Okay, so this is our 2.6, and this is our 3.9. And if you can get in close, you can see the difference of the pixel pitch between the pixels. So that's a 3.9, this is a 2.6. So resolution is going to be a lot higher on this one, but the other problem is that the processing is a lot more intense. So we can do far less panels on the 2.6 with one processor and one port than we can on this one. This wall right here, the 3.9, we usually use a 6-port Novastar processor. Because you can do multiple panels on one single port, so 6 ports goes pretty far. This higher resolution, we can only do a few panels, so we use a 16-port processor, so it eats up a lot more power. Okay, so for power for the LED wall, it's a lot more convenient to use what's called a SOCAPEX cable. And a SOCAPEX cable is a 19-pin multi-power send cable that has 6 20-amp circuits going through it. And so we've got 6 regular Edison males at one end, because we're only using our male output. But we do have distros that have SOCAPEX direct out of the distro for the 3-phase, which works really, really well. And it's a lot easier because you can eliminate a whole entire tail. So for our new panels, the 2.6 panels, these are PowerCon. And our other panels, the 3.9, are True 1. So they are completely different standards. This is the older PowerCon version, and the pin alignment is a little bit different than on a True 1. So we've got these specifically for our wall, and this goes up on the truss. And sometimes we're doing a really large wall, and so we need all of these tails to come out staggered to where they're going to go. So we've got 6 outputs all in different lengths. This wall that we're doing is going to be really, really easy, so we don't have to do much. Okay. So there's multiple ways to fly an LED wall or to put it up. One is to suspend it from the roof on truss span, but that gets really expensive in some venues because you've got union and some other factors of rigging to their ceiling. And so what we'll do is we'll use large lifts on either side, and then we can lift it from the ground, which would be the same span of truss. The other way that we do this is called ground stacking. We will actually either build it on the ground or we'll build a stage. We'll build the lower row, build a row on top of that with this truss vertical, and then we clamp it to it. That's a pretty popular way of doing it as well. All right, so for this Socapex, it's got these connectors that go right into each other and then screw in. So if you're familiar with an audio snake, this is basically a power snake. So you're sending multiple channels of power down a single line. So this really cleans up the truss and cleans up a lot of stuff, which is nice. So what I'm plugging into is what's called an L2130, and this means that there's 3 30 amp circuits. So the 3 legs of 3-phase is the XYZ, and this is the black, red, and blue. So I'm just going to plug these in. This is not a very big wall, so we don't need a lot of power. Okay. So the next thing we're going to do is we're going to fly our span sets, which is actually sort of a company name. It's not actually called span sets. These are called round slings, which is the generic. This is actually called steel flex because it's got steel cable on the inside of it, and a lot of venues require this because it's a fire safety issue. So for the wall indoors, we usually use our steel flex. It's not as flexible, but it works really good for our use. So since we're going to do 7 wide, we're going to do, if we had an even number, like if we were doing a 16 by 9, it would be 10 panels wide by 3 tall, and that would be an even number, meaning we would have to put one right in the middle. This one is an odd, actually, we would span the middle. So seeing as this is an odd number, we have to put one exactly in the center so that we can center it on the truss. But what I'm going to do is we're going to offset it slightly to avoid this with our Tomcat bolt together truss. We don't have a clean center like we would with the conical truss. So we're going to do it this way just for the sake of ease. Okay, all right, so now over here we've got our fly bars. And we've got our singles and then our doubles. And so for this middle one, I'm going to use a double. I think I mentioned these are brand new. I wasn't kidding. It smells like a new bicycle. So these connection points on the backs of the fly bar, these have to be on the up stage or the back side of the wall. So figure out which direction you want your wall to face. These are going to face away from it. And then always check, step back, make sure it's centered and that I guess the center doesn't matter on this one because we're going to offset it slightly. All right, so then you line these up so that they're meeting each other. There's a little bit of a pin and a hole so that they go together. It's always good to just kind of make sure they're just kind of pushed together a little bit. So now we've got our channel 1 is right here, and this is going to go into the first panel that's going to be on this side. So we'll start grabbing panels. Really important on these new panels is they have edge corner protectors because these pixels are closer together. So you have to pull these off, slap these back every single time you take them out and you put them back in again. And these have connectors on the tops and both sides and the bottoms. And obviously the logo orients and the serial number orients correctly, so you know that this is the vertical angle. These set in these little holes right here. Slap it up. I don't know why that one's not going in. So it sits in these little holes right here. Okay, so those tops are locked, and now the sides lock to each other as well. So we punch those in, make sure that they're lined up. You can kind of feel on the bottom on the other side. And then this kind of pushes them together. All right, then as you start putting more panels on, it starts to sort of bend a little bit downward with the weight of the previous panel. So you kind of have to push it together. I think these panels weigh just a little bit under 25 pounds. I had no idea these needed a break-in period. Okay, so this is our first row. And so now we're going to hook up power and the networking cables. And so our first power cable goes directly into that panel right there. And you can see it's already got power to it. And generally, we usually only do about 5 panels per circuit. So I'm just going to hook up some jumpers. All right, so these are our jumpers. We've got the 2 different ends of a power con cable. So the black is the out. The yellow is the in, and since this is an upper rack, we don't need to worry about really hiding this under anything because we're going to have more panels below it. All right, so we've got our first 5 panels on one of our Socapex channels of power. So I'm going to hook the second one. This is a slightly longer one, but this is going to go into this panel over here. So we're skipping those between those. And then this is going to do the next ones down, over, and then across. So now I'm going to jump between these. and power is good all along it. So the standard or protocol for these panels is Cat5, and we use Cat5 to run the processor. And so while the truss is down, we're going to run these networking cables through the truss so that it can be bundled together on the side out of the way of the show. And then I use different colors so that we know which one is top, which one is bottom. We're going to do two circuits for this, two processing channels, and see if that'll work. If it doesn't, then we'll add a third one. So we're going to run this to this top one, and then this orange one will be the bottom row. So I'm going to pull slack on this and just get it ready to go into a panel down below. And then we'll start networking. So this is our VX16S processor. We have a couple of these for multiple wall configurations. And in the back here, we've got a power strip that runs the computer, because we always have to have a computer with it as well. So I'm going to run power to that. All right. So there's our power, and then here's our two lines for our wall. And it looks like the yellow one is the port 1. So I need to leave slack at the bottom because we're going to take the wall up. So inside the back of here, this one is going to go into port 1. It's way over there. And this one's going to go into port 2. Which is right next to it. All right, then around the back, around the front side, we can actually start programming the wall a little bit. We can go to screen settings, quick configuration. Actually, it's going to be 7. The cabinet row is going to be 2. And then port 1 quantity is going to be 7. And then the data flow from the audience perspective, what is the flow? From the audience, it's coming up in the upper right. So we're going to continue to keep that. Then we escape. Then we can go down to display settings, and we can go to a test pattern, and we have all of our panels are working. And we can go to a grid. And we can find whatever we need. So for now, I'm going to black that out and go back to normal. And we're going to raise up the wall, and we're going to build the other 7 panels. So now I'm going to start in the middle. So this is only 14 panels. The majority of the time we're usually setting up walls that are 30 panels. So it's 10 wide, 3 high. So these have little triggers on them that you can lock the panels in a little bit easier. These little feet sort of, those tabs hit over those silver ones so they don't pop out. It's important when you're doing this that you're aware of everything around you so that you don't swing this into anything. Plug in the other network channel. Generally, I like to try to hide the cable so that it's not hanging and seen on the edge. And then the power that went into this one up here, we've got a jump from top to bottom. All right, so on this one, we have to jump out of this panel right here because this is part of a 5. So we have to jump out of this panel down to this panel to be able to share power. And with these, the power doesn't matter which direction it's going. So we've got these 1 jumpers, and then I can go across. So I've done 1, 2, 3, 4. So the power jumps up and down to only do a certain amount of panels, but our networking goes straight across from row to row. 1, 2, 3, 4, 5, okay. So then 3 can come so then we'll start our power again on this edge and then just go across to the other ones, which is going to be less than the normal. All right, so we've got our power that comes straight across from there, and then it stops here because we have power going into that one. So that's it for the power for those. And now I'm going to grab, these get incrementally longer and longer and longer, but this is channel 3, as it says right there. So this will go all the way over here to this panel. And then we've got lights on all those. The rest of these can just bungee onto a handle like that. But I'm not worried about it right now. Then our networking cables, we'll go straight across. Now, since these are on the bottom, I'm going to tuck these in over the handle so it doesn't come down below. Sometimes for indoor corporate events, we'll do skirting on the bottom of the wall, so it doesn't really matter. But especially if we're outdoors and we're not doing a skirt, it's important to keep those hidden. And funny thing about hanging a wall is it moves a lot. This doesn't happen when we're just lifting it or ground stacking it. All right. So now you look at all of the lights and they're all blinking the same cadence between red and green. That means that they have network. All right, so what we had to do is we had to run 3 channels of data to the wall. So we ran the first 5 panels with 1 port, and then the second 5 panels with the second port, and then we did the last 4 on the 3rd port. So that allowed the processor to process that information, sending it out correctly, but it's important you remember if you change your Cat5s that you make sure they're coming out of the right port. So we're running a screen test pattern on here. We can change this to be different test patterns as well so that we can see the really handy one is the text one, and it's almost too bright, but this actually shows you what size text will be visible. So it goes all the way down to 18 point. And so this is the 2.6 wall that makes that possible clearly. And then another cool thing that we've got in here is we have a audio video sync screen as well that clicks. So when you're trying to sync up your audio with your video, this actually helps you a lot, which is pretty cool. And it shows you the milliseconds that you're off if you need that. On this PC, we ran the Novastar software on it, and we're able to map exactly where the signal is going. So I'm going to turn this off. So I'll hide that. But on here, we discovered that we can open the mapping process. And so now on the wall, it shows exactly what port it is and what screen number it is from the beginning of that port. So on the top, we've got port 1, and it's panels 1 through 5, port 2, 1 through 5, and then port 3 is 1 through 4. So that's a good function of the Novastar processing. So that's the wall, and that's the process, and thanks for watching.